So now that we've talked about the asymptotes, well, what happens to the intercepts when you shift a graph up or down? So in this case here, you got a horizontal asymptote of y equals 2 because it's got a plus 2 at the end. But notice the intercept isn't this starting value, right? The intercept ends up being 5 here. Well, that's because you shifted the graph up. So let's graph this here so you can kind of see. So if I say y equals 3 parentheses 1 divided by 4, close that up, and raised to the x power, if I don't add 2 to the end, 3 will be my y-intercept. But since that 2 is being added, it shifts the whole graph up 2, so it ends up being 3 plus 2 to give you 5. So your y-intercept is going to always be the leading number plus the asymptote, or minus the asymptote if it's negative. So that's how that works. You're going to take your first number and your last number, and you're going to add them together, 3 plus 2. So what about this one? 4 times 3 to the x power minus 5. Well, your starting value is 4. Now your asymptote is negative 5, so it's been shifted down 5. So you should get negative 1. You can verify that on a graph. And at x equals 0, y equals negative 1. So it's just 4 and negative 5. So to summarize all that up, if the value of b in the parentheses, your base, is greater than 1, we got a growth problem. If it's between 0 and 1, it's going to be decay. It's going to go down as it goes to the right. Your horizontal asymptote is going to be whatever number is being added or subtracted at the end. If you don't have a number added or subtracted, it's y equals 0. And then your y-intercept is going to be the leading number, that starting number, plus your horizontal asymptote, up or down. So if it's a positive number, you would add. If it's a negative number, you subtract.